So, we are talking about polynomials, which are of this form, where you have some number times x to some power, plus some number x to some power, plus some number x to some power, and so on, where all the n's are integers. So you might have something like g of x equals 4x to the 7th plus 5x to the 3rd minus 2x squared plus 8. Something like that, where we are talking about a polynomial. Yeah. I can get them to you, show you what they are. So, we're going to talk about polynomials. What does the graph of a polynomial look like? Okay. Is it smooth, jagged, continuous, discontinuous? What's generally the graph? Okay. Yeah. When we talk about polynomials, some of the things. The graph. Now, if you can put this beside the picture if you wish. Graphs are continuous. Meaning there's no break ever when you talk about polynomials. There's no holes in it, no infinite discontinuities, no jump discontinuities, nothing. It's just a nice, smooth line. You don't get any jagged. So, also graphs are, and put smooth in quotations. Because we always get graphs that are curvy, no jagged points. Yeah. So when we look at the graph of this polynomial, if we got this, we know that's not a polynomial because we got a point on it instead of being smooth. Polynomials are always gentle curves. Now, higher degree polynomials might look like this on a calculator, or look something like that on a calculator, but if you zoomed in on it, it would look curved. So for polynomials, you always get gentle curves. Now, we've already discussed in behavior a little bit for polynomials, right? So the handout you have talks about it. You've got even and odd and positive or negative leading coefficients. You see that on your chart? If you look at the even, left-hand column at the top, it says, with a positive leading coefficient. Meaning, if you were looking at this, A is positive. So look at this. Can you tell if it's positive or negative, the leading coefficient? How do you tell? Guess what? On which side? What? Yeah. So, a key thing. If we have f of x equals a x to the n plus whatever, assuming it's a polynomial, if a is greater than 0, what's happening on the right-hand side? Yeah, it's going up. So it's going up on right side. If a is less than 0, what's happening on the right? What this means is we can look at just what's happening on the right-hand side and know whether the leading coefficient is even or odd. Now, it does not tell us if the coefficient, or if the degree, or the exponent is positive or negative. What we have to do is compare the sides. So, look at this one. Is this even or odd? It is odd, because they're going opposite directions. If it's going the same direction, it would be even.
What is
Base 0, then what happens? Then this would go away, and you'd go to the next term over. And if that was 0, 2, then if all of them are 0, you just get a flat line. Now, there's something called the leading coefficient test that you need to know. The leading coefficient test is for determining the end behavior, which is actually already discussed with us. And that's what's discussed on your paper. So, to use the leading coefficient test is looking at what is the highest exponent. Is the highest exponent even or odd? And then look at the coefficient of that. Is that positive or negative? If it's positive even, what does the graph do? Okay, it's positive even. The graph is doing this. Positive odd. From your perspective, up on the right, down on the left. Negative even. Both sides going down. You understand what we mean by both sides going down? We're talking about end behavior, the graph going downward on both ends. If we're talking about a negative odd, what's happening? Down on the right, up on the left. That means in the long run, the limit as x goes to infinity is negative infinity. So that's one of the things that you're going to be looking at is, yeah. Okay, then it's not a polynomial. Yeah. Then we get a fractional one when we get other more interesting things happening. So in that case, it's not a polynomial. No, polynomials are always smooth, never undefined. So this determines, oh, that's really ugly writing. End behavior. And this is what you see on the chart. If it's positive even, positive odd, negative even, negative odd. You can see that in the chart, right? You want to take? Now, I don't know if I showed you this notation before, the limit notation. Do you remember seeing that? Limit is x goes to infinity. Okay? This says what happens in the long run. What's happening in behavior? So if it's positive odd, what is this going to equal? Okay? As x goes to infinity, so you're talking about which side, left or right? Right-hand side, it's odd, it's positive, it is infinity. So, let's see, if f of x goes to negative infinity, if we're talking about a negative odd. Yeah, it goes to infinity. So we're talking about a negative odd, which means what's happening on the right-hand side. Down. If it's negative odd. And the left-hand side, which we're talking about, so we're talking negative infinity, so the left-hand side, what's happening? Going up. So this says what's happening to the function in the long run. F of 1 is limit f of x as x goes to infinity of a, so it's a negative even. What do we get? Negative infinity, because we're talking negative infinity, both sides are going down. On the right-hand side, it's going to negative infinity. No. So I'm just showing you, on the homework, some of the problems are going to ask you, use limit notation to describe the end behavior. This is what you're going to be doing. So, and you want to put both positive infinity and negative infinity. So you've got two parts for describing end behavior, what's happening on each end of the graph. Yes. Oh, so as x goes to infinity, that is still proper notation, but when it asks for limit notation, this is the notation to use. Yes.
So if it was positive even at the bottom, that's plus minus?
Well, no. Well, you would want to use two separate things. So if we had positive or negative even here, I'm just going to do the other one. Limit x goes to negative infinity of f of x. This is still a negative even. We would put or still negative infinity. So you'd put both of these. So that would be if you have a negative even problem. And there might be a question like on a quiz or test that says, if I give you this, you should be able to tell me what type of function it is. So if I told you these two pieces of information, what kind of polynomial is it? Negative even. You should be able to go back and forth between the two different things. If I give you one, you should be able to get the other. Now, some of the more details. So we're still working with f of x equals ax to the n plus bx n minus 1, etc. What is n known for this polynomial, known as? The exponent, we're going to use another term, is the degree. Have you heard that before? So n is the degree of your polynomial. So if it's a fifth degree, an eighth degree, third degree polynomial, that's what we're talking about. So what's another name for a third degree polynomial? A cubic function. If you're talking about a second degree, what would it be? Or a starts with Q? Quadratic. So when we talk about the degree, we're talking about what is the highest exponent. Now some rules about this. If we were doing a graph of, you don't need to write this part, a quadratic, how many zeros could it have? So second degree, how many zeros could it have? Okay, it can have 2. Could it have 1? Okay. Could it have 0? Okay, what if we're talking about a fifth degree? How many zeros could it have? Okay, so it could go up, down. So you get something like that. 1, 2, 3, 4, 5. Could it have 4? Let's see, if we went up, down, like that, but just barely touched the 1 point. Could it have 3? Yeah, if this one was up, could it have 2? Could it have 1? Could it have 0? No. Because one side is going up, one side is going down. It's got to go through 0 to continue. So if it's fifth degree, it does have to have at least 1. But could it have 6? No. Or 7? So what is the maximum? 5. So if we have a fifth degree or eighth degree, what's the maximum it could have?
8.
What's the minimum?
4. No, 2. 0.
0 for an eighth degree. What about a ninth degree? Maximum is? Minimum? 1. What's the pattern with this? Yeah, if it's odd or even. If it's odd, what's the minimum number of zeros you could have? 1, right? Because one side is going up, one side is going down. It's got to cross the middle somewhere. If it's even, what's the minimum? Okay, so we're going to go back here. How many zeros could it have?
has at most, if it's a fifth degree, what's the most it could have? 5. Then we say has at most n distinct zeros. So we said an 8th degree could have at most 8 distinct zeros. Our 20th degree would be able to have up to 20. How about how many curves it can have? So like the second degree, what's the maximum number of terms I could have? 1. How about with 5th degree, what's the maximum I can have? Let's say 1, 2, 3, 4. How if we had a cubit? The cubit could look like this. What's the maximum number of terms? 2. Yeah. So, has at most n minus 1 turning points. Okay? Is everybody listening understanding what we're talking about here? We're talking about what's happening now, a little bit more what's going in the middle. We know what's going on the ends with these functions. What's happening in the middle? Now we're going to get to a bit more complicated things.
Is it actually possible for it to loop in the middle, like
Could you do that? Would it be a function still? Okay? Polynomials are always functions. So it couldn't have a polynomial that did a loop. We could make a graph that did the loop, but it wouldn't be a polynomial anymore. Okay, we'll do it later this year. Okay. We're going to do some factoring of these. So, you guys start looking at this like, uh-oh, how do we factor that? What's the first rule of factoring you would always try? Yeah, what's common? Is there anything common in this? Okay, no. So we're actually I'm going to show you one of the more powerful techniques that you'll use in this class and in calculus. It's a substitution. I'm going to say u equals x squared. What does this become then? Now, can you factor that? What multiplies through 15 adds to the 8, or negative 8, I should say. So u minus 3, u minus 5. Now I can go back to x squared. X squared minus 3, x squared minus 5. Now, that's not always possible, but when you see something in the form to the 4th power, to the 2nd power, to the 0 power, or no power, we can use this technique and see it might be factorable. You guys understand what we did there? Okay. So, if you saw this, so some of these are going to be solved by factoring the question. So you'll get something like this. Say x to the 4, or x to the 6 plus, say, 5x to the 4 plus 4x squared equals 0. Solved by factoring. Okay, first rule of factoring, take out what's common, which in this case is x squared. Okay. Now we can look at it and say, now we don't necessarily have to do that use substitution, because we can say, what multiplies through 4 adds to 5? So we can say x squared And this is going to be x squared plus 1, x squared plus 4 equals 0. Do you see where it came from?
What do you mean?
I don't understand, like, well, I know you did, but I don't know how to do that on there.
Okay. Oh, wait, basically, because this is the form u squared plus u, and do you understand where this is coming from? Okay. So, that's one way of doing it, is just going to this form and saying, what multiplies before after 5? That's what he's done before, right? That type of factoring?
Yeah. Oh, that means you.
Yes, that's all I did.
What's the thing?
Yeah, but I did, instead of changing it to u form, I just left it as x to the 4th, because I know what it was going to become. There's nothing wrong with changing to u and doing the factoring that way. That is what's done a lot in calculus in some of the methods they use. Is you have to change it to a u form. Now, this one, if you recognize the pattern, it's not really all that important to change it to u if you can see the pattern without it. But if you want to change it, there's nothing wrong with doing it.
Is there a point where we need to know how to change it?
In this class, no, not really.
Would it take longer?
No, I mean, all I'm doing is just saying, if I change it to this form, say I'm letting u equals x squared, how would I factor that?
It doesn't end.
U. So this would be u plus 4, u plus 1, and then I just change it to put it here, u plus 1, u plus, or x squared plus 1, x squared plus 4. Now, how do I finish solving this? So, what would make this equal to 0? So x equals 0 is one solution. What would make this one 0? What? I or? How about negative I? Plus or minus I? So where they're coming from is I can say x squared plus 1 equals 0. What causes this part to be 0?
Well, would that be, since like you subtract 1, right, and
Mhm.
the square root of negative 1,
Yeah.
would it be the plus or minus square root of negative 1?
Yeah.
Or does like the plus or minus matter?
It would be a plus or minus squared to negative 1. So that's why I get plus or minus I.
Oh.
So this one would give what? 2i or negative 2i. So, I think on this homework it's only asking you for real solutions. So if you've got an imaginary one, you don't have to worry about it. Now we've got one more term. Have you heard this term before? Multiplicity. Or multiplicity of solutions. Have you heard that? No? Okay. And sometimes it's mentioned in Algebra 2, sometimes not. So I'm going to give an example where we have it, and so f of x equals x minus 3 to the 4th, x plus 2, x minus 5 to the 3rd, x plus 7 squared. What is the degree of this polynomial? It is not 4th degree. Close. Okay. Remember, if I multiply this out, this would be x to the 4th. And then x times x times x times x. So this generates an x to the 4th. Multiply times another x gives us an x to the 5th. Times 3 more gives us an x to the 9th, or 8th, and then times 2 more, you get x to the 10th. So this is a 10th degree polynomial. Right?
Oh, because x was 2 to the first power, right?
Yes. So now, what are the solutions or zeros to this polynomial? What are the zeros? X equals 3, x equals negative 2, and x equals negative 7. Now, multiplicity
is we're saying how many times does a certain solution occur? So, how many times does the solution x equals 3 occur in this? 4 times. So x has it. So the solution x equals 3 has a multiplicity of 4. Meaning it occurs, the solution occurs 4 times in this. Yeah. So this could be written as x minus 3, x minus 3, x minus 3, x minus 3. So 3 occurs as a solution 4 times. Okay? What would be the multiplicity of negative 7? 2. Because negative 7 gives us 2 different solutions. Or 2 of the same solution, not 2 different ones. 5 would have a multiplicity of 3. And what would negative 2 have as a multiplicity? 1. So multiplicity is when you're talking about how many times does a certain number occur as a solution. So to see it, you need to have the polynomial in this form, usually. Does anybody, any question about what multiplicity is, or what we mean when we say multiplicity? How many times does a certain solution occur? So I can write how many times a given solution occurs. So we're talking about, if we're talking about something that has multiple things, yeah. Nikki?
Is there an abbreviation for multiplicity?
Just maybe mults, periods.
Is that how
Equal 3, multi 4.
Yeah, I mean, assuming in this context, yeah, that would be obvious. That would be clear what we're talking about. So that is something you have to be careful of. You could, yeah.
x equals 3 multiplicity 4?
Yeah.